So last time we have run two different recursion style 1 and style 2. So in style 1 our thinking was smaller answer, my work and final answer. In style 2 our thinking has changed. For every element exclude or include. Okay, so we have solved the same problem using two completely different way. Wait is that okay, two completely different way of thinking. Now it's time to run the third and final recursion style, that was style 3 for row backtracking. Okay, so last time we have solved the same problem using two completely different ways of thinking, and style 1 and style 2. Now it's time to learn the third and final recursion style, so that was for loop backtracking. So see, so style 2 is almost based on the same recursion and backtracking ideas we have already learned. So the only thing that change is the way we think. Okay, so before writing any code, let's understand the thinking behind style 3. It was 3. Okay, style 3 for loop backtracking. So style 2 is style 3, sorry, style 3. What is style 3? So see, style 3 is current path and choose the next element. Okay, current path, choose the next element. In style 3 we do not think about include or exclude anymore. Instead we ask a different question, so what should I choose next? Okay, that's the entire idea of recursion 3. We already have a current path. Now we simply ask which element should I choose next. So let's understand with a small example. So we have the array. Our array is 1 2 3. Okay, our array is 1 2 3, and right now my current path is empty. Okay, right now my current path is empty. Wait, path. Okay, my current path is empty. Now let me ask myself one simple question: what can I choose next? Okay, can I choose 1? Yes, I can choose 1. Okay, can I choose 2? Yes, I can choose 2. Can I choose 3? Yes, I can choose 3. Okay, so see, so from an empty path I have 3 possible choice. Okay, from empty path we have 3 possible choice. So let's explore only the first choice. Suppose I choose 1. Okay, so now path is 1. Now I am standing at this path. I will so see, I am standing at this path. Again I will ask exactly the same question. Okay, I am standing at this path. Again I will ask the same question: what can I choose next? I can choose 1 again. No, I can choose 2. See, first I can choose 1. No, because I cannot choose 1, because see, because in the subset problem every element can be used only once, so I can choose 2. Okay, now I can choose 3. Yes, I can choose 3 also. It's look like this. Wait, I can choose 3 1 3. Okay, now again let's explore only the first choice. I choose 2. Okay, I choose 2. Now my path is this. So now I will ask the same question again. So what can I choose next? I can choose 1. No, I can choose 2. No, I can choose 3. Yes, so my path look like this now: 1 2 3. Okay, now my path is 1 2 3. Now let's ask the same question one more time: what can I choose next? Nothing. Okay, so there are no element left, so this branch is complete. Now recursion returns the, and because we are using backtracking we undo the last choice. Okay, first we undo the 3. Okay, we undo the 3. Next we undo the 2. Okay, see, now we back to the next we undo 3, and now we back to the back to at the part 1 2. Okay, let's ask the same question again. After 3, do I have any choice? No. So this branch is complete, this branch also complete. Okay, now we backtrack again, then we undo the 2. Okay, now we come here. Now I am back at the path, so let me ask the same question again. What can I choose next? I already explored the choice. I have already explored the choice next. I have already explored the choice of 2. No. Yes, let me ask the same question again. What can I choose next? I have already the choice of explore the choice 2. Is there are any other choice left? Yes, I am still choose 3. So let's explore that branch. Now my path is 1 3. So my tree look like this. See, now my current path is 1 and 3. Okay, my current path is 1 and 3, this one. Okay, now again I ask the same question. What can I choose next? Is there any element left? 3. No. So this branch is complete. Okay, so and we undo our last choice, we undo the tree. Now 1. So have I explored every possible choice from here? Yes, I have. Now I have explored. I explored 2 and explored 3. There are no more choices left. So I backtrack again. I undo 1 also. I will backtrack again here. Okay. Now I am backtrack at the root. So my path is this. Let's ask me the same question again. What can I choose next? I am already explored the branch starting with 1. So what's the next available choice? That was 2. Okay, so let's choose 2. Now our path is 2. Okay, my path is 2. Next, see, my current path is 2. Again I ask the same question. What can I choose next? Can I choose anything after 2? Yes, I can choose 3. Okay, so my path become like this, 2 3. Okay, now I am at 2 3. Can I choose anything after 3? No, this branch is complete, so I can return and undo my last choice. I can undo 3. Now 2, I can undo 3. Okay, now there are no more choices after 2, so I backtrack again. So I undo 2 also. Now I am in path, I am back. Now I am back at the root again. So I have already explored the branches starting with 1 and 2. Only one choice is left, so let's choose 3. Okay, so my path is 3. So after 3 there are no elements. Okay, so this branch also finished. So we return 3. So we undo 3 and I am at path. Okay, did you notice the pattern? See, at every step I ask only one question. What can I choose next? I never ask skip, take. That was style 2. In style 3 we always think current path. We always think like this. See, current path, choose the next element, next explore, then undo, then choose the next element. Okay, so say, and this is exactly why style 3 is called a for loop backtracking. Okay, the for loop simply tries every possible choice. Okay, every possible choice. Let me write down this tree. Need wait, this is my path. I have 3 choices. 1, from 1 I have 1 2 and 1 3. Okay, then 1 2 3. Next is 2 2 3 3. Okay, now see, so this is exactly why style 3 is called a for loop backtracking. The for loop simply tries every possible next choice. Okay, converting the thinking. Now let's convert the thinking into code. Okay, now we have understand the thinking. So the next question is, how do we convert this thinking into code? Okay, Mm, see, so first we need a container to store the final answer. Okay, so this is our final answer, so we need a container to store the final answer. So that's why we write this vector and result. Okay, why? Because every subset will be stored inside this vector. Now think about the example we just did. We had a current path. Okay, we had a current path 1, then 1 2, then 1 2 3. So we also need a variable to store the current path, so that's why we write vector int path. Okay, so see, this path keep changing during recursion. Now we need a recursion function. Before we writing a recursion function, let's understand one question. So see what information those recursion need. Okay, so it needs the array. Recursion needs a array. Okay, we see ty vector int and nums. Okay, recursion function needs the array, it's need the current path also, and okay, so it's needs the final answer also. And one more thing, how do we know from where we can choose the next element? We need an index. Okay, we need an index, so in start. Okay, so our function is ready. Let me write down. Wait, int main return 0. So first thing we need a vector nums of nums 1 2 3. Okay, then we need a vector of result, vector int, because it was subset we need a 2D vector. We see in path. Okay, written down here. We need function wide. Let's write on the back. Function name subsets only, sub. Okay, ect vector int and nums int rt start. I can write I also. This is just a variable name, you can write I, n, anything. Okay, vct vector int okay. Yes, see, notice something, there is no skip, there is no take. Okay, we only have written one question, what can I choose next? Okay, so and the variable starts tell, so this variable start tell as where our next choice begin. So our function is ready now. Now let's think. See, I am standing, wait, let's take small example only, 1 2. Okay, 1 2, I am standing inside recursive call. Okay, nums, my nums is 1 2, my current path is empty and my start is equal to 0. So see, is my current path a valid subset? this is my current part, so it's a valid subset. Yes, the empty subset is also a valid subset, so before choosing anything I should save my current subset. Okay, so that's why we write result dot push back path. Okay, because my empty subset also a valid subset. Okay, so now see, yes, my current now my current result is this. Okay, this line execute, now result become like this. So we just store our first subset. Now let's ask the same question we asked while during the tree. So what can I choose next? Current path is this, so my current path is this. I choose 1 and 2, so do I have only one choice here? Do I have only one choice? No, so I have multiple choice. Okay, whenever we have whenever we have to try every possible choice, what do we usually use in programming? That was a for loop. Okay, so let me write a for loop. I think ये बड़ा दिख रहा है थोड़ा. Wait, let me write a for loop. Okay, for int I is equal to start, I is less than nums dot size I plus plus. Okay, so see, why are we writing a for loop? Because I don't know how, I don't know which choice will be correct. Okay, so I will try every possible next choice. So see, now start is 0, we will write a for loop for int I is equal to start, I is less than nums dot size and I plus plus. Okay, means for, so this line means this. See, for int I is equal to 0, because our start is 0, then I is less than 2, 1 2 number, if 1 2 I plus plus. Okay, in iteration 1, when I is equal to 0, current choice is 1. Okay, current choice is 1. In iteration 2, when I is equal to 2, my current choice is 2. Okay, so this single for loop automatically tries every possible next element. Okay, see the for loop has chosen the first element I is equal to 0, so nums of I is equal to 1. Okay, so see, if I can choose 1, how should my path change? Okay, if I choose 1, how should my path change? Before it was like this, after it's look like this. Okay, so for this, how can we write a code path dot push back nums of I. Okay, so then I have written here 2D Victor, but I just want 1D. I think I have written, no, same, yes, nice, right. See, okay, see, if when I have written path dot push back nums of I, so see, before it was like this, after execute this line, so path is now like this. Okay, so now a tree look like this. So we have choose 1. Now let me ask the same question again. So my current path is 1, what can I choose next? Can I answer this myself? No, Recursion will answer it. So I will write, see, I will write this. sub nums I plus 1 path result. Okay, now let me explain you why I plus 1. Say why I have written I plus 1. My nums of I is 1 2, I is equal to 0 1. Okay, I is equal to 0. We have already choose 1, so should I choose 1 again? No, that the next choice should start after 1. So that's why I have written I plus 1 means I is this I plus 1 1, this index 1 element is 2. Okay, so means see, next choice start from index 1. Okay, next choice start from index 1. Now my path is 1. We call I sub this line I plus 1. Okay, now how start is equal to 1. Okay, now start is 1. So what can I choose next? That was 2. Okay, see, recursion is doing exactly what we did while drawing the tree. Okay, it was doing exactly. Now say we need let me, how can I explain this? Okay, see, okay, we need why. So why do we need pop back? So see, let's see our code. Result dot pushback, where is that? I have not right. Path. Okay, now see, my code is like this. See, after recursion return, now recursion has finished exploring everything starting from 1. Now let's see what happened. Current call, so nums nums is equal to 1 2. Now my path is 1 and start is equal to 1. Okay, so we called sub nums I plus 1 path and result. Okay, so recursion has explored everything. It explored 1 1 2, then recursion return the current state. So we see, now we are back in the same parent call. That was 1, still current path is still 1. Okay, so our tree is, so this is our tree, my current path is still 1. Now as see, let me ask you one question. Have I finished exploring the branch starting with 1? Yes, I have finished. Now I want to go back to the root. Okay, my current path is 1. Now my root is empty. So can I go with still keeping 1 inside my path? No. Okay, I have to remove this. Okay, if I want to return to the parent, I must remove the last element that I added. That is exactly why we write this. Okay, path dot pop back. You know na, you got it, why we need this line. So how can see, now path is 1. Okay, when we execute this line, my path become empty. Okay, so now our tree just become this only. So this is called, so see why this is called undo. Earlier we made one choice, path dot pushback 1. Okay, pushback nums of I, we have made this choice, this. So now that branch is finished, so we reverse our last action, path dot pushback path dot pop back. Okay, so it's become like this. Whenever we add, we must remove rater. Okay, whenever we write, we have to remove rater. Whenever we add, we have to remove rater. Okay, choose explore, undo. Okay, this is why this is called backtracking. Backtracking means go back to the previous stage as you can try another choice. Okay, so see, current is empty. When we choose one, so it finish here, so we go back to one, we undo. My current is this. Okay, we have backtrack. Now we have already see we now we have try. Now we have to try another choice. That was 2, path 1 2. Okay, see, suppose I do not write this. Okay, where is this line? Okay, so my current path is 1. Now the loop continue. Next iteration choose 2. So now what happened? Path, see this thing, path dot push back nums of I, current element. Okay, we push. So now my path is 1 2, but wait, I want to start a branded new branch from the root. I want like this too. It will start from here only. Okay, if we do not write this, so that's wrong. Without pop back, every new branch start with old data. See, that's it. So this is the heart of the backtracking problem. Okay, every time we choose something, we must undo it before trying the next choice. Otherwise the next branch start with the wrong path. Okay, now let's write a complete code. Okay, so now we have to understand the thinking, and every line has a reason. I think let me write this on here only in LeetCode. Let me write down in LeetCode on ray. Void sub vector int nums int start vector int and path vector int and result. Okay, next we have to store the current subset result dot push back path. Okay, we have to try every possible next choice folder. We write a for loop int I is equal to start I is less than nums dot size and I plus plus. Okay, then we have to choose part dot push back nums of I. Then we have to explore. Okay, sub nums I plus 1 path, then result. Okay, undo. How can we undo? Path dot pop back. Okay, let me write here result final answer vector int result vector int path, then call the sub non-zero path result result. In last we are just going to return a result, return result. Okay, see, let me submit, it works. Okay, so we have solved this problem with 3 style also. Okay, style 1 return based recursion, and style 2 is skip and take, include, exclude, and style 3 is for loop. Okay, so we have right. Okay, next is try run this try run. Yes, that's all. I think so. The time complexity is same. We go off into, I think, wait. See, an important point is that style 1, style 2, and style 3 all have the same time and space complexity. Okay, for subset problems, the difference is not performance, the difference is the only way we think. Okay, style 1 is get the smaller answer and build the final answer, and style 2 is for every element decide skip or take, and style 3 is build a path and choose the next possible element while using a for loop. Okay, see, same problem, same complexity, but the different is only thinking. Okay, so next we are going to run the patterns. So that's it. I have done rather than just way. I'm not running. It's simple. See, that's all.